Welcome to The Green Urbanist, podcast for urbanists fighting climate change. I'm Ross. Hi everyone, welcome back to another episode. My guest today is Jake Attwood-Harris, and our conversation is all about low-carbon architecture. Jake is Sustainable Design Advisor at Hawkins Brown, where he led the development of the free open-source Hawkins Brown emissions reduction tool, also referred to as Herbert or HBIRD, which is a whole-life carbon calculation tool. Jake works across all project stages, developing and reviewing key sustainability strategies and targets. His work is at the boundary between architecture and engineering, working with passive design techniques to create comfort in buildings before using modern technology where it counts. If you don't know Hawkins Brown, they're one of the biggest architecture and urbanism practices in the UK, and they design really stunning and sustainable buildings. In this episode, Jake and I discuss the practicalities of achieving net zero carbon by 2050 or earlier, taking an evidence-based approach to designing zero carbon buildings, the challenges of retrofitting existing buildings for energy efficiency, and why it is essential that architects are trained and educated in sustainable design principles. This episode centres a lot around architecture, but even if you're not an architect, like I'm not, there is a lot in here for you about the role of buildings in achieving net zero carbon in general. There is a lot of detailed information in here, actually, that really blew my mind and changed my perspective on these issues. I also realised listening back that sometimes we don't always explain all the terminology that we use. So just so no one gets lost, I'll give you a heads up on some of these terms now. We talk about this concept of whole life carbon, which is an approach to designing buildings that takes into account emissions from the building's entire life, including construction as well as operation. So it's really the most accurate way of assessing what are the emissions associated with the building. We also talk about Hawkins Brown's Revit plugin, which they use for assessing carbon emissions and which you can download and use. If you don't know what Revit is, basically it's a 3D modelling software used by architects and engineers, which has a sort of database functionality built in. So you can actually store data in the model, which makes it really useful. At some point, Jake gets quite technical, talking about using Revit, which I think will be really useful for those of you that do use the software. If you don't worry, we move on after a few minutes and go back to talking about more general topics. So just a heads up on that. And lastly, at the beginning, you will hear Jake mention something called Scope 1, Scope 2, and Scope 3 emissions. Scope 1 relates to emissions directly from burning fossil fuels. Scope 2 relates to indirect emissions from energy use. And Scope 3 relates to embodied emissions, in this case from building materials. When people talk about net zero carbon, often they only include Scope 1 and Scope 2 emissions and don't take account of Scope 3, which is obviously a problem, and that's basically the context in which we're talking about these terms. Okay, just to give you a bit of a podcast update as well before we get into the conversation. In mid-May, in about a month's time here in England, we're hoping to have our social distancing rules relaxed. So I will actually be able to do podcasts in the same room as people again, which I'm really excited about. So I'm pushing back some of my episodes till after that, so I can actually speak to people face-to-face, but in a COVID-secure way. I'm really looking forward to that, and it means better audio quality for you listening, and I think it's just a better energy having a real conversation with someone rather than doing it over video, which is what I've been doing for the past 8 months or so. Of course, we'll probably still be having video calls with people who are outside London. So there might be, also to say, there might be a bit of a gap in episodes over the next month as I sort of wait for the restrictions to be reduced, and also just give myself a little break. So don't worry if you don't see any episodes coming out, as we regularly do. Just hold on a little bit, and we'll see how it goes. And actually, just speaking of audio quality, for the first 15 minutes or so of this episode, Jake's audio is a bit muffled. I mean, it sounds like it's coming through the internet, which it is. We then had a bit of a technical glitch where we had to restart the recording, and actually after that, Jake was using a better microphone, and so the quality gets abruptly much better after that, after about the 15-minute mark. So that's just a little heads up as well, and in case you're wondering what is going on with the audio. Last thing is just to say a reminder to follow the podcast, The Green Urbanist, on social media. Instagram, Twitter, and LinkedIn. You can also email me. I love chatting with people. If you have any questions, if you want to give any feedback on the show, I love chatting to people who listen, and I'm happy to have a conversation. So please do get in touch. You can also find out more about Hawkins Brown and Jake and get in contact with Jake via the Hawkins Brown website, which is also in the podcast description. Thank you all very much, and please enjoy this really interesting conversation with Jake. Well, I wanted to start off, we're going to talk about a variety of things, but I think we can start off at the really high level. Obviously, the UK has promised to reduce carbon emissions to net zero by 2050. What are your thoughts on achieving this? And I guess in particular, the role of the construction industry and the built environment in achieving that.
Yeah, so I think it's really fascinating. I think first things first, I think it's fantastic that we did that. It's a little bit cart before horse, without really knowing how we're going to get there. But I think it really is very helpful in helping set a destination, something for us to aim towards. The other thing probably to mention as well, just off the bat, is that there are a lot of people, particularly, Extinction Rebellion and other kinds of groups related to them, Architects Climate Action Network would be one of them, who want to push for an earlier date, who would like to push for something more like 2030.
Right.
And 2030 is what we see. Some councils are setting those kinds of dates as well. However, I find that kind of difficult. I mean, as much as that's another way of looking at it, that's looking from the top down. So that's looking at basically what's the scientific evidence and when should we reduce to zero carbon by, which probably is around 2030. But when can we reduce to zero carbon by is a completely different question. And that, well, to answer that question, I think you need to really get into the weeds of what is zero carbon, what is the scope. So generally, for companies and actually for governments as well, they define in the three scopes 1, 2, and 3.
Okay.
But the kind of issue, and often then for, so if we were Microsoft or some other large company that defining our carbon emissions, we'd put our energy use into scope 2, and we would include that in our calculations, so that our direct energy bills, which is something we as Hawkins Brown do as well. We do assess our whole impacts as a company. But for example, if we were building a new headquarters building, that would not go into our scopes 1 or 2. It's actually even questionable whether it would go into our scope 3, or who would account for that? Who would account for all the energy used to produce those bricks, to produce the energy in cranes that are coming onto site, and all of those activities? And it's one of those things that slightly slips between the cracks at the moment, or is kind of offshored in a way, in that these things are being done in China, or not just China, but there's a lot of tone of the debate which says China's got such a huge impact, it's such a big polluter. Well, if we're buying the products from that region of the world, then really who should be accounting for those products? I think is a big part of the story. So in general, I mean, what can architects do? That goes back to what we talk about is whole life carbon. So we break that down into kind of simple categories, which is embodied carbon in building materials generally. So the carbon that's released as part of producing those materials. The operational carbon that throughout the lifetime of the building, which is largely energy, which can be heat, electricity, but also water and other kind of operational things. And then we have on the kind of other side, so they're the impacts. And then we have the kind of positive things that we can do to take away from the carbon impact of a building. So that can be biogenic carbon storage, which is basically normally timber or other plant-based materials, which can be locked away inside the building so that they're not rotting like they would naturally. Or it could be some kind of renewable energy generation, which basically is reducing carbon because it's replacing a more dirty electricity grid that you would use as current. And then there's kind of one final thing that we, maybe for urbanists or for master planners on a very large scale, which is carbon sequestration in soils through kind of rewilding or landscape remediation. So basically, you can do things in all those categories, and some you want to increase the later ones that I said there, and you want to decrease the embodied and the operational. But really, there's a whole range of different strategies to do that, depending on the site, depending on the client, depending on the age of the building,
right?
As well.
I think that's a really important point about, how do we actually define our responsibility? Which emissions are we responsible for? And this is particularly important, I think, on the sort of city or local authority scale. And you'll see, some cities who are saying they'll reach net zero. And when you look into the details of what they're considering is part of their responsibility, they're excluding, for instance, their airport. And they basically just don't want to take into account the emissions from air travel. So it's like, but who is responsible for that? Like, we're going to miss huge chunks of carbon emissions if nobody's taking responsibility.
Exactly. And something I've been trying to push is proportionality is very important. I don't like this every little helps message. I mean, every little does help. There's another famous quote, which is not from an advert, from Sustainable Energy Without the Hot Air, with David McKay's book, which is that if we all do a little, we'll achieve a little. That's how percentages work, right? If everyone does 10%, then we get 10%, and what we need is like 80 or 90%. So we need some people to do 150%, and some people to just scrape 60%. We need big changes to reach these kind of goals. But what you said is also particularly important. So we need to take everything into account. So that means, we need to get a holistic picture of where are actually our carbon emissions coming from. And when we look, going back to more my specialism, when we look at buildings or master plans, what we see is something like 70% of that impact will be in the frame. I haven't got these figures in front of me. I probably should have. Something like, it varies building, obviously. Something like 15% in the facades, 10 to 15% in the mechanical services equipment, and then it really jumps down in the later ones. So more like 2 or 5% in your internal finishes and whatever else might be in the building.
Right.
So there you can see, you can talk a lot about finishes. You can get a 90% improvement in finishes, but in the building as a whole, that's still only a 2%. Whereas we can get a 5% improvement in the structural frame, and that's more significant than, replacing all our finishes with cork or with timber or whatever it might be. So the same methodology should apply in a city or kind of town or whatever regional national scale you're looking at it. That you have to do the big wins first, and you have to go for the big things, which, to their credit, the government have been doing. Their strategy largely so far seems to be focused around energy generation and the kind of idea that, if you fix the energy, you kind of fix everything else. That's not really that true, but particularly when you focus on transport energy as well. But I think one of the reasons that we're taking a whole life carbon approach and focusing on embodied carbon is partly because it's the architect's main responsibility. It's what we're specifying,
right?
But also because those emissions can easily be hidden, and the government, for obvious reasons, are a little reluctant to include imports like that, imported carbon figures. It's going to help them a lot in doing their calculations. But if we want to reduce the whole world, what we can't get into a position of doing is, that kind of developed or first world countries, however you want to term them, are counting their own, have lots of nice clean industry at home, and then basically just offshoring all that dirty industry to places which either have a bad score already, like South Africa, which is never going to catch up with our other countries, or which don't care about their score, because that's not really a moral victory at the end of the day. It's a particular, and that's really another thing behind this, taking this embodied carbon approach to design, is it's about UK manufacture as well, and promoting UK manufacture. And that we want, if we assess all all manufacturing accurately, then that should encourage British manufacturing. Whereas if we're doing this weird biased approach that we're starting to go along at the moment, which currently those things are excluded from the calculations, and we start taking it very seriously, then we're massively disadvantaging British products.
Right.
And that's obviously, for a range of reasons, something we don't want to encourage.
That's a really interesting point. I'd never considered that before. Yeah, it makes perfect sense, though. I mean, do we have many indigenous sort of building material? I know you obviously have paving stones and slate and this kind of thing, but is it still sort of a big industry here?
I don't have the figures on kind of, percentage of UK economy or whatever it might be, but there are, there's all kinds of things that we do here. We have active steel industries just about still, depending on when this goes out, to be honest, based on the recent news. But there's all kinds of things that we do often get from the UK. However, another issue really, and why we try and take this carbon approach, which is an evidence-based, science-based, calculated approach, is that, a lot of people like to talk about localism and sourcing materials locally, which is great and is ideal in an ideal scenario. However, when you do the full calculation of what impacts a material's total embodied carbon, what we see is that transport is normally in the range of around 5% of the impact.
Okay.
So, for example, one thing I was talking about with a team today was about aluminium cladding panels. Now, it doesn't sound good if we ship aluminium in from China. However, that shipping is only about 5% of the total. And what really affects the total for something like aluminium is very energy intensive to mine and extract. So actually, what we need to be looking at there is what energy was used for that mining process and what energy was used for that the extraction and then the manufacturing, smelting, and all that kind of thing.
Okay.
And it basically it's the same for there are some principles you can think about here. One is does it go in a furnace? Is it ceramic? Is it brick? Is it metal? Has it been melted or put in a furnace? And then was that furnace gas or was that furnace electric?
Right.
Because that's generally, and effectively what that means is it encourages largely French at the moment, or because the French electricity grid is majoritarily nuclear and therefore low carbon.
Right.
And so is half of London's energy network comes from France directly as well, which is a big part of our low carbon strategy in the UK. So that what we're trying to get towards is less of this narrative approach, because it's kind of infinitely complex, all the things that go into making a building and all the different approaches you could follow. And what we try and do with the teams is choose the best narrative, choose the best approach for your project, but give me a number and then show me, let me compare it to our standard options. And it should be lower, really, unless there's some other justification.
Part of this whole challenge, I guess, of getting the evidence is, there's it's not as easy as just clicking a button on your computer and it tells you how much carbon your building is using. There's sort of a lack of tools, isn't there?
Yeah, it is a little bit of an issue, and to be honest, it's even something of an issue with the tools that exist. So we there are some commercial tools on the market that are used commonly. There's generally two. So maybe it's better if I don't mention all the names because I don't know all of them off by heart. But generally the ones that are used most are One-Click LCA and Tally, as far as I understand it. And then there's a few that have been developed by design firms. So generally what we find is most structural engineers have some methodologies for working this stuff out. A few service engineers that have caught up, and then globally there's maybe 3 architecture firms that I'm aware of, including ourselves, who have some kind of software around this. And then there's several of us who have other tools which have been released. Actually, one that probably deserves a bit of a kind of honourable mention is Field and Clegg Bradley released their, I forget the name off the top of my head, but their carbon calculating tool, which is a spreadsheet-based tool. Very useful, really great.
So our approach in-house has been to develop what we call Herbert, which is the Hawkins Brown Emissions Reduction Toolkit, which is actually now evolved into a kind of a range of different tools, some internal tools and some which we release externally. So if you type HBERT into Google now, you brought to a page on our website, and that's where we share version 1 of our Revit plugin tool, which is also open sourced on GitHub as well for anyone that can read code and wants to modify that code. What you get in that download is you get a few different template files for different versions of Revit, and you get the installer for the software, and you get some kind of guidance on how to use the software. And what it does is it sits within your normal Revit model. It is possible to integrate it with your own templates. However, it's quite a convoluted process, so we don't tend to do that. It's generally easier to take our templates and modify them. And what the templates have is they have some custom schedules, which is basically the main part of the tool. And then they have, on a different design layer, they have a series of materials. They have a load of different walls. It's around 50 at the moment. And they all have different materials applied. And what we've done is by working with the ICE database, which is the Inventory of Carbon and Energy, which is originally a piece of research done by Bath University and is now owned by a company that was folded out of that called Circular Economy. It's the only freely available large UK-based database of embodied carbon values for building products. So we use that as a baseline. It's generally what most other people are using as baselines at the moment. So we have those 50 or so materials, commonly used building materials. And then what you can do, that's the way, because when materials aren't loaded into a template, Revit forgets them. So we have to do it. That's the kind of workaround that we did to keep that data in there. They have what I call, I think it's special parameters. Sorry, I'm forgetting the terminology off the head. But they have extra parameters that we store in there. And then those parameters are read out in our custom schedule. So what that allows you to do is you can make any volume you want. You tag it as one of those materials, which are named HBA_wood or whatever it might be. And then when you go to your custom schedule, it will tell you wood, and it will tell you all the different kind of things. We have factors to account for a kind of average impact of transport and all the different stages that it might be. So the stages I'm referring to, referring to the it's in the recent REBA and RICS guidance. And there's a British standard around whole life carbon calculation, and it defines stages from A to C. And so we apply factors for each of those stages. So that goes from extraction of the raw material, manufacture, transport to site, construction on site, in use, maintenance, the factors for each of these things. So we take the standard data from the ICE database, which is A1 to A3, and we apply a series of factors based on some research that we did in collaboration with UCL and Dr. Yair Schwartz, and then we multiply that by the volume, and that will spit out a figure at the end. And what it also does is when you press the button, the little logo, which isn't meant to be Mickey Mouse, but everyone keeps telling me it looks like Mickey Mouse, when you click on that little orange logo, that will then take those numbers that are in your schedule, which you can actually just view whenever you want in the schedule, and it will draw you a nice graph, which is called a tree graph, kind of blocky Mondrian looking graph there. What that will also do, and I should probably explain this, is there's an option on there. There's either a final option or a draft option when you click that. And as part of our development, basically the reason that we open source this piece of software is because, we want to encourage the industry to do this. We think this is the right approach for the industry as a whole. And we really, if we're going to meet any kind of deadline, even if it's 2050 or sooner, we really need to move on this fast. And as part of that, we store some of the data that's got sent on a centralized web server, so we can use it to improve our tool. So that's basically the difference between final and draft. Is one of them sends the data to that web server, one of them sends it to a black hole. But that's all explained when you download the tool in line of our GDPR policy. So that, basically the approach in doing that, in building this software, is really about speeding up the process. This stuff can be done. There are plenty of specialists out there. There are specialist companies out there who do this, but it's a cost. And I think, as we know from other parts of architecture, the more you bring in specialist consultants and specialist analyses, the kind of less often they can be done. And so in a way, the less impactful they are sometimes, if they're very large and complex. So what we're really aiming at, and I think that's what most other people are aiming at that are building these pieces of software or tools, is speeding up that process to enable it to be done as fast and as early in the design process as possible. That's a real goal.
That's it sounds incredibly sophisticated. It really kind of takes a lot of that, I guess, research and specialist work and just kind of condenses it into that, click of a button type of thing. It sounds like a real game changer.
Well, it's a bit, I mean, yeah, like it isn't a click of a button in a way. So I'll give a project example. So one of the first projects that when we were first starting to develop the tool and looking at it, it's actually used in the group as we analyze the swimming pool. Now, the swimming pool has a standing seam copper roof. Whoever tagged it initially, however they modeled it in Revit was not an accurate 3D model. Revit is not accurate, is not modeling things accurately in 3D. And they had tagged something like a 20 millimeter thick copper roof. So the first time we ran the assessment, it was, it was something like 80% copper is the main impact. So that was an accurate assessment of that model. However, that model was not an accurate representation of the volume of materials in the building. And I think people will understand this from cost, trying to get cost data out of Revit. And it's one of the reasons I refer to this as carbon accounting, because it's very, it's very similar really to developing cost figures in that you need to take the same kind of assumptions. So if I've got however many meters squared of internal wall build-up in my building, then I don't take it's not the most accurate way to do it to take the volumes directly out of Revit.
Okay.
For a whole range of reasons. Partly because Revit just works in layers. It doesn't have 3D kind of elements to these. Elements like that are extruded in kind of thin layers. So what it can't account for is things like voids and air. You don't put in a material for air typically when you're doing that. You assume that the layers run completely evenly all the way down, like a rainbow. Whereas, in studs, it basically can't calculate the volume of stud work in an internal wall, which you would think sounds like the basics of what Revit does, but it doesn't. It doesn't do that. And so what we've had to do is we have got workarounds for all of that.
Okay.
Effectively, what it is we produce default materials, which are studs plus air in a typical cavity wall. So we have a whole range of these default materials so that people don't have to change the way that they model in Revit, but they have to tag the right materials to the right thing.
Right.
So I kind of use that example to say it is a kind of click of a button software, but you have to follow the modeling methodologies and you have to, what we do in-house and what's actually been the majority of our time really is developing those design processes, review processes, programming guides, all of that kind of thing, so that so we can integrate this properly into a design processes and have it accurate still,
right?
Where it's in-house. So yeah, that's taken a little work, and it needs a little more work, and there's a lot of guidance coming out now.
The sort of, I suppose, message I'm getting is that we as a industry, let's say the architecture or the construction industry, we obviously we should have already have been doing more sustainable design, more sustainable kind of construction for years. And we're really just catching up now because we see the effects of climate change. And because, governments are finally waking up and setting, deadlines and that kind of thing. And yet our sort of methods and our technology haven't really caught up to the point where we can do it quickly and easily. And I'm thinking particularly, it's great for a big successful architecture company like Hawkins Brown to be able to develop something like this in-house and then share it. But I'm thinking of all the small architects, who don't have sustainability people, and they just, it must be a real struggle for them to sort of catch up with this.
Yeah, I think it is. It's something that I know kind of keenly because there's kind of a cap on the size of an architecture practice that I can work for. And generally, this is the smallest practice I've ever worked for. And we're the 6th largest in the UK or something like that.
Wow.
So, there's there's a lot of the majority of practices are more like one or two people. One of the reasons that I mentioned the Field and Clegg Bradley tool is that's a spreadsheet based tool, so anyone can use that. That has access to Microsoft Excel. It takes a bit more using. You have to know what you're doing, but you can learn to do it that way. In America, there's the government produced a database which you can develop API access to. People that know what that is, so basically remote updated access to their centralized database rather than kind of sharing spreadsheets or something, which has enabled some certain firms, at least one firm that I'm aware of in America, has built their own plugin in Grasshopper for Rhino, which actually sends queries to that centralized database, pulls the product data and sends it back into your models. That kind of stuff's possible with government support. But I think we're kind of slightly in the UK, we're kind of waiting for the government or for, the REBA or UK GBC or the BRE or whoever it is to kind of catch up and do that work or get the kind of funding to do that piece of work. Because what we have at the moment is a series of private companies managing their own databases and no free, large enough centralized database of product information. And that's, and I don't think I explained some of the intricacies there of what we do with our tool is we use the ICE, the Inventory of Carbon and Energy, as a baseline. So that is a study of the whole UK industry based on specific examples, and it averages out data. And for some things like steel, it gives you an average data for worldwide, for European, for British, and those kind of figures. However, as we get further into the project, so that's basically what we use for kind of stage 0 to 2. As we approach kind of stage 4 of our project, what we seek to do is to find more and more EPDs, and that's an environmental performance declaration, which is a little like a kind of FSC certificate or something like that, that a material or a product itself, like a whole window assembly or something, might have this EPD. Right. And that's the data we really need because that's specific to the product. So, what I was talking about before, like, is it made from coal? Do you burn coal or does it come from solar panels? Right. That data is in this product, and it actually specific data information about the energy used to ship it from wherever it's mined to wherever it's processed, for example. So that's really key, is getting that detailed data. And that's what a lot of these private companies can do. And they manage big databases like that. And that's actually specifically what we said we wouldn't do as Hawkins Brown, because I don't want my job to be managing a database of product data. And also I'm probably not in the best position to do that. So I think the hope is that the government or some other kind of industry body will take that on at some point. But until now, there's a bit of a patchwork of different approaches. And that's why we developed Herbert to be separate to that and to be very, I think of all the tools on the market, in my experience anyway, Herbert is the most open. Like you can just download those schedules. There's an option in Revit. You have to go slightly through the menus, but you can download any of the schedules as just a spreadsheet file or just a pure CSV, like comma separated variables, which is just data with commas. And you can put that into Excel. You can turn it into columns again, and you can do whatever the hell you want to it. You can change all the values. You can just keep your volume information, and you can change the A to C values for the product specific or whatever you want to do. You can keep all the product values and change all the volumes and see how, you can do any data you want, and you can see exactly where all of our information comes from, and you can update it as your project progresses like that. And that's basically what we encourage people to do. Generally, the ISO are a little bit high, so we like to use higher ones at the start and then give people a target to whittle away at, so they can get preferably, both whittle away at the impacts and then also increase all the benefits until we have a little kind of balanced type graph. Until they both of the bars are the same size and you have reached whole life 0 for your building. So there's a lot of complexity that is needed and research to get to a point where we can really be confident about talking about whole life 0 buildings.
Yeah, there's a big issue with the performance gap, isn't there? Between, obviously one thing is materials. When you're talking about, our model says this is what the carbon emissions of the materials are. In reality, it might be different. There's also the performance gap of, in the model, our building performs this well in operation, but then in the real world, obviously human beings are not rational. We, maybe, leave windows open and then have to turn the heating on, and that's another whole issue, isn't it?
Yeah, it is a big issue. There's a big performance gap. I think in terms of embodied carbon, it's maybe slightly less, or there's different things. There's less things coming into play there, but it is still an issue there. And that, I think, there's probably a wider point from that actually, which is about architects' involvement in the whole construction process and lifetime of a building. And it's something that we, particularly at Hawkins Brown, we'd like to build. We don't like to get involved in projects where we're not going to be involved in the construction process. And what we're pushing for more and more, and I know it's part of what Architects Declare and a lot of other groups are pushing for, is for POEs, post-occupancy evaluations, to be carried out. And not just to be carried out, but to be carried out with us involved. You know, it's better if there's a third party that can be a little bit more objective. But actually, we tend to think that architects are quite a good objective third party compared to someone hired by the client directly. Okay. You know, we have an industry membership, and we have like a wider kind of, you know, reputation to uphold. So I think architects are quite a good position to carry out POE work. And but you know, apart from the individual building and the individual client, it's just really good for us to understand, does that building actually work? Yeah. Or are people, for example, propping open that door because they want to prop it open because it doesn't open properly, or, you know, because it is too stuffy in that room? Are we specifying too high levels of air tightness or not enough air change rates? In which case, you know, should we rethink our approach to some of those things? I think it's vital. Quickly, in terms of embodied carbon, what that might mean is you get substitutions on site. So that's kind of where that comes in. And you know, builders substitute paint, substitute flooring, substitute these types of things, and that's good to follow all the way through as well, and follow those impacts, and then carry out the life cycle analysis again at the end of the building, and then actually just one more thing, which is we're starting to get really, really interested in, and could easily be its whole podcast or you know, dissertation, doctoral thesis, is the impact of refurbishments. It's vast. Right. You know, you think of a 60-year lifetime of a building, and the difference between flooring or you know, tenants that come in and refit on a 5 or 10-year life cycle. Well, it's double, isn't it? You know, and actually they can be really quite large if we're talking about you know, like structural things like suspended floors or suspended ceilings, or lots of racking for display racking for a shop, for example, like made out of aluminium and steel. That's large, those impacts. Steel stud internal walls, that's quite a large impact again, often just scrapped at the end. So yeah, like being involved throughout the process of construction and use, and even which we have done with some of our longer clients, going back to older clients and reassessing some of our own buildings and the rest of their estate, and devising strategies for management and which ones should be extended. I think those types of services, that's the kind of way that we're going to really truly get to zero carbon. And yeah, because the statistics are something like 90% of the buildings that are going to be here in 2050 or already exist in this country. Yes. Yeah. So I think as architects, we need to get much more used to working with what's there rather than, you know, building whole new worlds.
That's a whole extra issue around the need to retrofit existing buildings to be more energy efficient, because, you know, if you do that on a large enough scale, it means you just need less energy in general, and that makes it easier then to provide, you know, renewable energy. Do you have any thoughts on, you know, the challenges around that? Is it something that, you know, we could actually do in this country, is like retrofit every building?
It is actually, I think in this country, it's more challenging than most countries. And I think that's something that, well, it's not just me saying this. I mean, you read most of the guidance that's coming from professional organizations. There's a huge, and even just the Climate Change Committee, the government's own independent panels are saying this. There's a massive gap between particularly residential, which is not actually something we get involved in as a practice that often, small scale residential or retrofits of small scale residential projects. But so that's a little outside of what I do day to day, but that is the issue. You know, we have what was and may still be, I'm not sure the rankings at the moment, but what was the largest passive house scheme in the world or in Europe when it's fully built out. Phase 1A is already on site of Agar Grove in Camden. That's big passive house social housing project. It's great. It's very low carbon. It's got air source heat pumps. It's all electric. It's fantastic. But, you know, that is actually far, far, far easier than taking, you know, however many thousand people might be in the other council estates in Camden and seeing what we can do there.
Right.
Now, as part of that, that is an existing estate, and we did move people from the existing buildings that we thought that we needed to demolish to the new ones without moving anywhere else in between. By the way, it was a very good decant of people going directly in, and people's flats were actually designed specifically for individual people, which is really brilliant. But the issues come with all those other structures and some of that post-war housing that really wasn't built to a very high standard and is covered in thermal bridges. But actually, if you just look at, there's good statistics about the percentage of solid wall properties in the UK, i.e. zero insulation. And you might think, oh, we can just put insulation, which you can. But really, when you get into the details of that, and it's the same for basically any heritage building that has any kind of planning, well, you know, we're not going to go and overclad the Houses of Parliament with the insulation, are we? Which would be the most efficient way to do it. So, okay, if we're not going to overclad it, then that means we're going to go internal insulation. But then that means we have to go around all of the window details, all of the floors detail. And then if we have structure, you know, if it's maybe a 60s building or 50s building or 70s, it's got structural concrete, reinforced concrete, and it's got something like balconies or terracing, then you've got rebar running right from the inside to outside. So if you do insulate, you're actually going to cause real bad problems with mold growth, because when where you get thermal bridges are about a differential. Right, it's where is the easiest path for heat or coolth to transfer into the building. So when the entire wall and windows are terrible, like, you know, for let's say like the Barbican probably used to be, like I imagine at some point it had an awful like thin glazing and those big structural concrete balconies. If the entire building is acting like, you know, a heat exchanger, then you've got no difference. So there's no one point where that's going to be acting as a thermal bridge. Now, if you then insulate that whole facade, but you've still got this big concrete balcony sticking into your building, you're going to get a line of mold. Generally, what happens is the floor below the balcony in someone's kitchen or bathroom, particularly where there's a lot of moisture being created, you'll get a line of mold along that. And you see this, by the way, this is something that you'll notice in old developments, and it actually kind of it can make it completely unviable. It's really sad, but you know, if a building's built like that, imagine the cost. What do you do to the balconies? Do you take them all off and put new bolt-on steel ones on? Do you try and somehow put a thermal break in that balcony line? Do you try and internally insulate every flat, as in the walls and the floors and the ceiling of that flat? But then you're exposing the structure to more cold and changes in conditions than it would have had before. Because actually, if you internally insulate an old stone wall property, it can fall down if you put too much insulation on, because then the stone walls effectively become like a brick, a cliff face are exposed to freeze-thaw cycles. So it's really difficult, and it's a particular problem in the UK because we use heavyweight construction for residential architecture, and that any other country in a similar climate zone, we're in a Northern European climate zone, and basically the rest of Northern European climates use lightweight constructions generally. The reason that we don't traditionally is because we have radiant heat sources. We have a lot of forestry and a lot of coal, particularly as well. So our buildings, and you know, most of the houses I've lived in London they're single, and the one I live in now, it has no insulation in the walls. It may have some in the roof or something that's been put in later on, and it has chimneys, and those chimneys would have been heated pretty much all day for most of the periods. They also would have had, a lot of these houses, they would have had an oven or some kind of Rayburn or Arga type thing, which is both an oven and a heating system for the house. And that would have been pumping this waste heat into the stone or the brick and, you know, the big thick brick chimney breasts, and heating the whole house. And you would have had as well either a maid or a kind of housewife type figure that is in that house all day using that house. And it's important, you know, when we then move to a system, you know, where most people using these buildings are commuting, they have less people in them than they used to have. You then remove all those internal gains, and you know, whereas in Victorian times you might have had 3 families living in a terraced house, and they actually, if you insulated that up, it would have been horrible and stuffy.
Right. Now
you have, like, you know, a bachelor living in a 4-bed house. and suddenly, and with these big brick walls and leaky roofs and things, and you know, a design which is designed to ventilate as much as possible and to smooth out temperatures. So there is a bit of a fundamental problem there that we have that other countries don't have. You know, when you look at Sweden and places, they have a more traditionally they're building these more lightweight constructions. And when you have, you know, when your walls touch your foundations with no thermal break, how do you bring that up to spec? It's very difficult, actually. It's a thing. I think what's happening now is what you're seeing a lot is the British government and a lot of the town councils and a lot of the, you know, these new regional mayors and people, they're putting in these theories, and what they're generally doing is they're doing their own buildings first. Yeah. And we've got a lot of those kind of projects. And I think they're going to learn through example. You know, I'd love to give some specific. There's one project, I think I can talk about this anonymously enough, which actually the original site was a castle at one point and then a prison after that. It's built onto the bedrock, you know, and it's there's not a simple answer there for how do I make this a zero carbon building. And that is effectively what we've been tasked with. And but on the other hand, I think this is fantastic, and this is why it's designed. This is why it should, in my opinion, sit with architects and planners, because it's a design exercise. There's not a magic piece of software that tells you how to do this. Right. There isn't a magic product that you just stick onto the top of the building or stick on the roof and suddenly it's a sustainable building. It's about understanding your client, your site, you know, everything that you normally have to understand when you approach a design project like that.
That's fascinating. I really didn't know any of that detail before, so that's really like kind of opened my eyes.
The kind of annoying thing is, and I think people get a bit sick of me talking about detail, but the detail adds up. Yeah, you know, and then it adds up, and then it makes huge differences overall after a little while. And yeah, it's tricky. There are some people that are specifically talking about this stuff, and there are some very good approaches, but it's difficult. And I don't think anyone's even thought. I know the National Trust are looking at this. I think we may have even I saw a competition and some new job roles being created for someone to kind of manage their carbon. But that's a hell of a task, right?
Thankless job.
Know, trying to get all these palaces that are designed to actually waste energy because it was that they wanted to have as many fireplaces and even fake chimneys to look like they were wasting even more energy than they had. And you know, it's a fundamental about turn to turn these kind of pleasure palaces that were never even really designed as homes, and to kind of take all of that stuff and try and get it to be zero carbon and completely self-sufficient is it's a big challenge.
It almost seems like there's a separate, I don't know, I'm just thinking about doing this on scale. As you said, there's no easy answer. It almost seems like there needs to be some work done around the sort of standard typologies. I mean, how many... Yes. You know, 1930s semi-detached houses are there that probably have quite similar designs. You've got the council flats and that kind of thing.
Yes, well, that's actually why, when you look at the statistics, the council-owned buildings perform significantly better than private-owned buildings. And I think that's one of the main reasons behind it is that they can do things on scale, and they can you get the cost efficiencies. There's actually... there's a company called Parity Projects who effectively do this, and I really like their approach. And they basically try to, the same way that councils will do whole estates at once, they try and organise for private roads. So you may do 2 or 3 roads. You know, London, for example, and a lot of the UK, the estates were built by the landowners that were country estates originally, and often they were built around factories or something like this. So you have hundreds of homes with basically the same construction system. And some of the same, dimensions and all that kind of stuff. So they need the same products. They need the same overall approach. They need the same kinds of planning permission. Yeah. And these are all the things that slow it down. However, you can apply for planning permission for an approach to, for example, overcladding facades on a street in a particular borough, and then just apply that throughout the entire street. If you can apply for it all at once, if you can bulk buy the insulation, if you can have builders that learn on the first house and just do it on all the preceding houses. And so you do all these air tightness and thermal bridging details properly. You really say, like, that's the way to do it. But I think it's a really excellent approach what they're trying to do like that. So they try and organize that with local councils and then basically go and kind of sell it to the local residents and say, you know, you can do this for $5,000 when it would normally cost you 20 or whatever it might be. Right. But I think that would, in my kind of ideal world, we'd have the government going out and kind of promoting those kind of things much more heavily. And then I guess you have similar issues with all of the existing buildings as well. Like that's possible for homes, but like architecture is still a craft. So we've worked on quite a lot of Dennis Lasdon projects, which is fantastic, a real kind of icon of mine, I think, in architecture industry. But as I said before, brutalism, it was when this kind of technologies were being developed for structural concrete, and you get a lot of thermal bridging and a lot of very poor U values on windows and a lot of those buildings. And they're often even built, I don't know why, but they look like heat exchangers. They have things sticking out. Like if you look at the Barbican, for example, it's not a Lasdon, but if you look at the Barbican, it looks like a heat exchanger in your computer. It's literally designed like a radiator. They are a particular problem with those buildings, but it can be done. You can bring them up to spec. And actually, one of the things that I always tell our teams work is, what spec? Why are we bringing this building up to modern spec? Does someone need to sit in this corridor all day long working? Because that's, typically what we're doing, what we're specifying is, if we go to kind of best practice standards by CIBSE or by ASHRAE or something, or one of those building services organizations, for offices, that will be 20 to 22 degrees all day, all year. Okay. That's the kind of typical that we're designing to. Now, that does make sense and is needed if you're sitting still. And people may have noticed that working from home, that your house needs to be slightly warmer. Yeah. Because if you're not doing anything at all and you're wearing office attire, you actually need to be kept at very consistent temperatures. However, if you're in a cafe, what we've all, and we often design cafes in, let's say an art gallery cafe or a library cafe, we'll design it to those levels. But then we've all also been in a cafe that's just in a courtyard, or in Venice, sitting out in the piazza in December wearing a kind of blanket. So that's perfectly acceptable. Covered markets, glazed streets. I talk about a lot. These are more traditional British, kind of archetypes for that type of space. And so I think the solution to a lot of those projects is it more adaptive reuse than it is just refitting and upgrading, because fundamentally some things just will be, you'll basically have to build a whole new building inside them in order to make them modern standards. Yeah. And if you do that, you make it smaller. There comes a point with some buildings where, in my opinion, it's just not worth it. And so what I prefer to try and get the teams to do is to imagine other scenarios that don't need that level of performance. Right. So, and that can be really bold. That can go to the level of, why don't we knock the roof off and turn it into a skate park? That could go to the level of, why don't we knock all the walls and make it into a covered market? Or it could be, like I said before, what if, we reimagine this. Let's say it's a 19th century office building. They're particularly difficult. There's quite a lot of them. Office or factory buildings. They're single glazed. They're solid walls. Yeah. Well, what if we use it for playground? What if we use it for cafe? As I said before, these kind of public uses do not need, a lot of the time they take place outdoors as well. And if it has a roof, that's a benefit. It can be used for a longer period of time. Or even something like a sports hall, which needs cooling a lot of the time. So there's creative ways around a lot of these issues, or even something else we don't think, how a box within a box type approach. So you have a shell. You have an existing shell, and then rather than trying to go around every little bit of detail and window, like I was talking about, accept that you're building a building in a building. Accept the reality and build a building in a building. There's some great examples of projects like that where you just use the existing building as a weather screen, and then you can do a really lightweight, really natural material, nice padded kind of insulated box inside, and just do that. And then, outside, that could be your office space, which is these great conditions, but your corridor doesn't need to be those conditions. Yeah. So the rest of so I think there's a lot of space for creative reuse here. And that's actually, I'm not even sure it's possible without these kind of creative approaches to design. And just to bring it back to whole life carbon, that's why I find it really interesting, because it's not tick these BREEAM tick boxes. I'm qualified in BREEAM, but everyone, I know how much everyone hates BREEAM. It's not retrofit first, and that's the only good thing to do. It's not timber first, and that's the only good thing to do. It's kind of agnostic, and it's stylistically agnostic is my kind of like overly academic way of talking about it. It is, design the best approach you can, give us the numbers, and let's improve it. It's always going to be specific to a client and approach. And you can, for example, the kind of office example, you can balance a whole load of things up and down. Well, if we brought it up, we could make it super efficient, but it would use, one good example is moving from double glazing or single glazing to triple glazing. Actually, when you do those calculations, basically largely because of the weight of triple glazing, it's not worth it in a whole life. Really? The whole life figures, because it's just the weight of the extra support you need for the structure and all that stuff over a 60-year life cycle of a building, it's going to be more carbon than you're going to lose by just using double glazing. And there are some very good double glazed units, by the way. Like, people tend to use triple glaze and double glaze as shorthand for U values, but they're not. You can get a double glaze that performs better than a triple glaze. So there's complexities like that fall out of the figures that you can't do from a kind of principled approach, and which become design challenges. You can reduce your comfort requirements. You can, increase your renewable energy generation. There's a whole series of things there that you can pull up and down and balance and change the scope and change the brief to accommodate. And I think that's where it's actually a really fascinating piece of kind of discipline, and also why, in my opinion, it's a design role. It's very much a design role.
Yeah. How important do you think it is that architects, urban designers, planners get adequate training in sustainability, or is it enough to sort of have experts like you on hand?
Well, in one hand, it's vital because we have such a huge impact, in the world. And while we don't specify anything directly, the client is always responsible. At the end of the day, we do make a lot of recommendations that have massive impacts. And something like 40% of their figures are a little strange because we spend 90% of our time in buildings in the UK. So they're obviously going to be responsible for the vast majority of emissions, right? Like, that's statistics again, this is the basics. But then again, I would say I don't even consider myself that much of an expert. I am in some ways, but I also, I studied architecture part 1 and 2. I've worked my entire career as a sustainability kind of consultant, expert type person. But I've always tried to sit a little halfway between the engineers and the designers, because I find that that's really useful a lot of the time. And often they basically need a translator. Stuck myself as translator some of the time. But I do tend to think that architects should have more of the kind of training that I have in general, which is that, I usually, before I talk about carbon accounting, as a kind of equivalent to cost, where architects don't calculate that, we're not quantity surveyors, but we talk about cost all the time, and I think you should be just as competent and to the same kind of level of detail. So, when you first start estimating at stage 0, 1, 2, whatever it might be, often our clients like us to try and start at 2, which doesn't make any sense. But when we first start to look at a project, you want to have a vague idea of what's the cost per square meter or square foot, anyway, in the world, and it's the same thing with carbon. What are the kind of archetypes we're looking at here? What's the likely kind of impact? How are we going to get to 0? What's our kind of broad approach? And then as you go through, then, at some point, and the point is, though, you don't get the quantity surveyor until whatever stage it might be. Maybe it's 4. They don't come in until late in the project because, like I was saying about any kind of analysis, whether it be operational energy or, whatever analysis you might do, they're expensive, and you don't want, the client doesn't want to do them a load of times, right? So what we need to be able to do is we need to be able to reduce that before those experts come on board. We can't just say we need to just pay loads more money to experts because that fee is going to come from somewhere else in the project, right? What we need to have is we need to have designers that are able to reduce without necessarily being able to completely accurately calculate, but you need to be able to reduce that using an evidence-based approach, which is not to say calculating to, I think particularly some of the early studies we did, and I probably can't say this for sure, but I think some of them may even have like a 20% error margin, particularly the very early ones we did. But what they do is they start conversations. And if we, if it's got a 20% error margin, but we think we've improved it by 40%, we've improved it. You know what I mean?
Yeah.
And if we've improved it between stages 0 and 1, and otherwise we wouldn't have, then that's a big win, right? And that's key. And the main reason it's key is the planning system, because by the time your project's got planning, you've locked in 2 major things, which is generally your structural system is locked in. And that's because the planners seem to mostly care about facades, right? They care about facades and heights of buildings.
Yes.
And so your window positions are going to align with your column positions, and your height is going to relate to the structural frame. And then the color that you color it in your planning submission is probably going to be what they try and hang on to as well.
Yeah.
Now, you go back to what I said before about the percentage of various different parts of the building. Structure might be 60 to 70%. Facade could be kind of 15 to 20, 30%. So you've locked in, maybe 90% before planning. But before you get planning, the project is still risky to the developer.
Yeah.
So they're very unlikely to have brought a quantity surveyor or someone to do an in-depth carbon analysis before that point. And yet they've already locked in. You can't go back and change it to timber because your bay sizes won't mix or those kind of things. So, in the same way that we do with costs, architects and planners and designers, when they're doing, and this does go into an urban scale, there are lots of things you can learn about building heights and all that kind of thing, which in relation to this. Some people would say never go above 3 if you want to have 0 whole life carbon, for example. You need to factor that stuff in from the very earliest point, so that you don't just turn around and say, "Oh, it's not possible."
Yeah.
No.
Yeah.
We'll just have to build it out of steel and aluminium anyway.
Okay, very, very well answered. I want to bring us on to the final question that I ask all the guests, which is, we're obviously at a pivotal moment for taking action on climate change. Really only have a few decades to make massive changes. So from your perspective, what do you think needs to happen, or what would you like to see changing in the coming years?
Yeah, sure. I should have prepared a great answer for this. I mean, the first one obviously is the thing that, I don't want to sound like a broken record, but until it happens, I kind of do just keep saying the same point, which is that we need to calculate whole life carbon. We need to include scopes 1, 2, and 3, and we need to include imports to the country. And that basically, even if it's inaccurate, we need to get everyone used to right now the full scope that we will need to actually reach these 0 targets. Because if we're not, again, another example that's similar to the glazing is aluminium louvers. So even in the hottest of climates, generally, when you do the whole life assessment and you compare the amount of energy that the louver blocks to the amount of energy that it takes to create the louver itself, generally they come out bad. Basically, they're not a sustainable feature. They are basically just, a kind of, it's a comfort thing rather than an energy saving thing or a carbon saving thing on a whole life point of view. Now, if you incentivize purely looking at operational, we'll cover all other buildings in the UK in aluminium louvers. So we're architects and just the industry in general needs to be working towards the principles, which we're going to have to do when we're, assessing this stuff accurately. And I think that's what we've been focusing on, and why I said I worry less about error margins than I do about processes and programming and techniques and scope. And what we try to do as much as possible is the full scope, the full that we can possibly do, and putting numbers to whatever we can put a number on. And then next time we make those numbers better. Right. And then we use that as a benchmark and we make it better. And then we query it with people, and we collaborate with universities, and we work with anyone that we can find, and we improve those numbers. But what that does is it allows us to get this into the build program, so that we have the standard series of questions. We have review forms that we use at different REBA stages to assess the buildings. We have appointment letters. We have spec clauses, all of this stuff, all of the things that you need for whatever else it might be in the building. We have that whole kind of infrastructure set up so that we're able to calculate the true cost of carbon. Yeah. Because if we purely focus on what's convenient to calculate, we make the wrong choices. Yeah, that's fantastic. And I think a really, good message maybe for other architects who are listening right now is,
if you want to start, taking this approach and bringing in this sort of evidence into your work, you're not going to get it perfect, but just get started and you'll get better as you go along.
And one of the things, because I realize I spend the entire time talking about carbon, and it's not all I care about. And actually, tend to be one of the people that's like, let's look at the bigger picture more. But from my point of view, it's the same approach. And we refer to it as whole life design or life cycle design, which is not just whole life carbon design. It can be whole life whatever you want design. Whole life social design, whole life financial design, whole life whatever. And every other kind of part of environmentalism falls into that. So, the impact on flooding throughout its life cycle, the impact on whatever else it might be. It's a great framework to get used to. I would encourage everyone to read the Reba Guide to Calculating Whole Life Carbon and get used to talking about these A to D stages of a construction cycle. And it's a great, it's really useful just for talking about buildings in their entirety and their whole life. And the other thing, just one more advert, was the Letty Embodied Carbon Primer has become a really useful document. It's the London Energy Transformation Initiative. Okay. We were part of that as well, but it's being really used and it's got some really nice guidelines. There's a lot out there. There's a lot more coming. But read whatever you can, I think, and catch up on this.